All right, so here's a quick little spiel on single replacement reactions, also known as single displacement. So you guys have this down in your foldable. If not, it will be down in your foldable. But let's just state it again. It's when you have a single element plus a compound reacts to form a different single element and a compound. All right. An example would be like down here, we got a single element plus a compound. And it's going to react to form a different single element and different compound because two of the entities are going to swap spots. So here's to break it down. It's essential thought process. Identify the blank and the blank. You're going to do cation and anion. So we haven't really used those terms a whole lot. Cation is positively charged element, and anion is negatively charged element. Usually it starts with positive, ends with negative. All right. Cation and anion, not cation, not onion. Cation. So, yeah, it's kind of like cat, or cathode, positive. Lithium, I got to figure out, this isn't my periodic table, this is Shaden's thing. Put that here. All right, if you don't know the charge of lithium, you look on your periodic table, and lithium's right there, and in that column, it's a +1 charge. So lithium is a +1 charge. Potassium is also a +1. And then you got chlorine. You got chlorine, and it's a -1. All right. So I don't know what to do. So let's go to the next step. It says switch either the cation or anion depending on the charge of the lone element. Hey, what's my lone element? It's lithium. It's a plus. So I'm going to switch it with the other plus, which is potassium. So Jaden, my lithium and potassium are both plus, so they're both being switched. That's what's going to do the swap.
Absolutely.
There you go. So potassium is going to be by itself, and lithium is going to be with chlorine. All right. Write the formulas for the products. That's the next step. After you switcheroo it, you write the products. And I already know the charges because I wrote them out over here. +1, -1, that's an overall 0 charge. If it was a +2 charge, I'd have to crisscross it to make it sure that's the overall 0 charge. Last step, balance. Well, not quite the last, almost the last step. Balance the equation. 1 lithium, 1 lithium, 1K, 1K, 1 Cl, 1 Cl. It's already balanced. I don't have to add any coefficients. And then write the states of matter if you can. So typically, if you got a metal, it's going to be solid, and if you got a compound, it's going to be aqueous for these single replacement reactions. Solid, aqueous. And that's going to make way more sense after doing the lab when you see it with your own eyes. And that's pretty much it. That's single replacement reaction. So we're going to do a couple examples, and then that'll be it for notes. So first thing, Mg, Na, and NO3, we got to figure out what the charges are. So Mg is in the second column, which is 2+ charge. So I'm going to put a little 2+ above it. And then sodium and nitrate. Sodium is in the first column, so it's a 1+ charge. And nitrate, hey, that's not on the periodic table, but it looks familiar. NO3, that looks like a polyatomic ion. Nitrate is right there as NO3 -1 charge. All right, -1. So my lone element is positive, so it's going to switch with which one, the positive or the negative? It's the positive, so the two positives switch. And this is going to be sodium by itself plus MgNO3. So I got to make sure MgNO3 is a correctly balanced molecule, so I crisscross the charges and make it MgNO3 2. That way the overall charge, 2 times minus 1 is minus 2, 1 times 2 plus is 2 plus. 2 plus minus 2 is 0. I got to balance it. I got 2 nitrates, so I need a 2 in front of there. That gives me 2 nitrates and 2 sodiums, so I need a 2 to get 2 sodium. So I'm putting it all together. Right now I'm like predicting my product. Am I going to have predicting the product on the test Friday? No, this is the third test. So this is what we're moving towards. States of matter. Metals are solid, compounds aqueous. S, A, Q, S. There's one little thing we forgot to mention. What if this reaction doesn't occur? So this reaction might not occur. So I might not have had to do any of that stuff. I might just have to put NR, which says no reaction. Oh my gosh, Connor, you're probably not going to know how to do this. You're not really paying attention, are you? Cool. Okay. Let's pay attention here. Come on. All right, so I got to look at the activity series. So, in the activity series, that's on the back of my front cover. There it is, activity series. I got a whole bunch of elements. They're listed in an order. The ones at top, the ones on the top are going to most readily oxidize, which means that they're the most reactive. So, Mg versus Na, do they even switch? No. This is on the back of the front cover, purple. So wherever your purple sheet is, there it's there. It's kind of like a purple sheet. There it is. Mg and Na. We gotta decide, is Mg stronger than Na? Is it the big kahuna? Mg is lower than Na by a little bit. It's not strong enough. So if they're doing like a tug of war over this nitrate, which one's stronger? Na. Sodium is. You got it. Na. So Na is going to win out. But Na already has nitrate. The big kahuna. It's the big kahuna. So is anything going to change? The answer is no. I didn't need to write any of that. I just need to put no reaction. This is a fallacy. Sodium's not going to get... This is like in magnesium's wildest dreams. Not going to happen. So all we need to do is put NR. So, looking at lithium versus potassium in that previous one, lithium is stronger than potassium. So lithium should end in the compound. Okay, will this reaction occur? Lithium ends in the compound? Yes. It wasn't originally in the compound. So that one we had to complete. So really, right after step 2, we should look at the activity series, because then we could potentially not have to balance and do all that other stuff. Oh yeah, one last one, and then we'll be done. We got Cl2 is -1, calcium's 2 plus, and iodine is 1 minus. We're just doing this quick for the sake of time. Negative. So the single element is negative, which means it's going to swap with the other negative one. You got it. So chlorine versus iodine. Well, let's wait, because maybe we don't have to do this. So chlorine versus iodine. Is chlorine stronger? Here's another activity series. Yes, chlorine is stronger, so the reaction will occur. All right, so that means iodine is going to be by itself, and chlorine is going to be in the compound. I wrote it as I2 because it's one of the 7 diatomic elements. Remember, you got H2, N2, O2, Cl2, F2, Br2, I2. 1, 2, 3, 4, 5, 6, 7. If they're by themselves, they're always I2 or Br2. That's why I wrote that. Calcium is 2 plus, chlorine's 1 minus. We got to crisscross it. Put a 2. 2 chlorines, 2 chlorines, 2 iodines, 2 iodines, 1 Ca, 1 Ca. It's balanced, and we're good to go. Oh, states of matter. If I don't know that chlorine gas is a gas, that's all right. You could just leave it blank. Sorry, I'll put it higher up. If you do know it's a gas, you can put a G. I mean, on the periodic table, it's red. So that means it's a gas. Any compounds are going to be aqueous. Then iodine is going to be a solid because it's black on the periodic table. But something like that, I'm not going to be asking you for states of matter because it's not one of the common ones. All right, and if you're curious, activity series of halogens is already written in your booklet. It's right here. I would write it. And what this is saying is the one that's higher up is going to be more reactive. It's going to be the stronger one. It's going to be the one that ends in the compound at the end of the reaction.
Are these planets new?
No, they've been here all along. All right, and that is single replacement reactions.